This experiment is about measuring the specific latent heat of fusion, which is the energy needed to change 1 kilogram of a solid to a liquid without changing its temperature.
Let me talk you through what we're going to do. We are going to put roughly equal amounts of ice into each of these funnels. And then we're going to turn on the heater. We're only going to turn on one immersion heater. And we're going to see how much ice melts because of that immersion heater. Okay? Now, the other one is set up as a control experiment, because what happens to ice naturally in this room?
It melts at room temperature.
It will melt. So this one on the left-hand side is going to see how much ice would melt just because it's warm in this room. Whereas the other one is going to see how much ice melts because of the heater. And we're going to run it for about 5 minutes. I'm going to put the immersion heater on to 12 volts. Here I have an ammeter, which is in series with it. And here I have a voltmeter, which is in parallel with it. And what I'll do is I will set the voltage to about 12 volts, and we'll record it on the board. And then we will leave it, time it for 5 minutes.
Okay.
And what we'll do is we'll get the mass of the measuring cylinder with the ice that would have melted anyway, and we'll get the mass of the cylinder that melts because it's got a heater in it. And if we take them away from each other, we can actually see how much ice has melted just because of the heater. Right, that is 100 grams. Yeah, 100 grams. So put 100 grams into this one. That's a lot.
Which one is that?
And that's the one without the heater. And we'll put 100 grams, hopefully. Yeah. 94.
Oh,
97. Into the other one. We must put some ice. Okay, just make sure the immersion heater is completely covered with the ice. Turn this on.
Miss, I thought
It is at 12 volts, because I was doing one earlier. And press go. Right, so all we do now is wait. 59. Right.
You can see there is more water in the right-hand beaker, which was the one with the heater.
Much more water has formed underneath the immersion heater one. And if we just lift that up and out for a minute, that's just my immersion heater, zero this and put it on there, then the mass of that is
Miss, isn't that one still dripping? So you want
203 grams. Right, and the second one is 195 grams.
First of all, we need to work out the energy. And energy is equal to power times time. Now our power for electricity is current times voltage. So we do the current times the voltage times the time. Our current was 4.4 amps and our voltage was 12 volts, and we heated it for 5 minutes, each of which is 60 seconds. This gives us an energy of 3,168 joules. The mass of the beaker with the water in when the heater was on was quite big. It was 203 grams. And if we looked at the beaker, it had a lot of water in it. When we looked at the mass of the beaker and the water with the heater off, it was only 195 grams, and there was much less water in the beaker. If we look at the two, if we take away the mass of the one without the heater, we'll be left just with the water that was melted by the heater. So if we look at 203 grams minus 195 grams, only 8 grams was melted by the heater. The last part of the calculation is to work out the latent heat of fusion of the ice. And this is equal to the energy needed divided by the mass of the ice that was melted. Now our energy was 3,168 joules and our mass was 8 grams. So our latent heat of fusion of ice works out as 396 joules per gram.